Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly. Welcome to the webinar. The webinar will begin shortly.
Hello everyone and welcome to this Breakout C presentation. My name is John Howarth and I'm the moderator for this session. The session is entitled The Essentials of Pumping Station Maintenance, presented by Kevin Gaunt from the Pump Centre. There will be a short time for questions and answers at the end of the presentation. The presenters' details will be shown during the Q&A session should you wish to contact them for further information. Please post your questions using the Q&A button in Microsoft Teams. We will deal with as many questions as we can within the available time. Thank you. And I would now like to hand over to Kevin Gaunt. Kevin, can you please share your screen?
Hi, John. Thank you for that. I'll share my screen and we'll make a start. So hopefully you can now see my slide.
Not yet, Kevin. I can't.
Can you see it?
I'm still seeing the title slide at the moment.
Okay, just bear with me a second.
Yeah, no problem.
Yeah, it should be. There we go.
That's it, Kevin. It looks like it's
that's it. Yes. There's always a little glitch, but we've just found it. Hopefully that's it out the way. So thanks very much, John, and good afternoon, everybody. Yes, the presentation this afternoon is all about pumping station maintenance and what I've called the essentials of that activity. The topics I want to look at, there are two main areas really. One, just a few minutes looking at why we need to carry out maintenance in the first place, and then I'll move on to look at some of the key components of essential maintenance, particularly those that are time-based with respect to pumps. I'm going to specifically look at the issue of lubrication, which is a bit of a Cinderella really within maintenance. It's often not given the importance that it probably deserves. So I want to spend a minute or two looking at that, and then I'll finish off by looking at some of the ancillaries around pumping stations that also need to be looked after if we're to ensure that pumping stations operate as they're intended to do. So to start with, why bother with maintenance? Well, there are three sort of areas that I've highlighted here as being impacted directly by maintenance activities, or possibly more correctly, impacted by a lack of maintenance or good maintenance. Efficiency in the first place, a lot of talk about pump efficiency, and maintenance has got a real contribution to make to maintaining efficiency of our pumps. And there's also then two other areas which are quite similar in a lot of ways, but reliability. So will kit continue to work as it's intended to do so, and also predictability. So will it do what it's supposed to do? So there's some key areas that we need to consider. If we look at efficiency in a bit more detail, there are a number of reasons why pumps may start to lose their efficiency over time. If a pump's fitted with packed gland seals, then if they're not correctly set up, you can get heat generated, and obviously that heat comes from somewhere. And any heat that's being generated is coming straight out of the power that's being put into the pump itself, so results in or is seen as an inefficiency. Another cause of pump efficiency reducing, of course, is if the clearances, wear rings or impeller clearances are incorrectly set. Many pumps rely on those clearances being as small as possible, and if as a result of wear they're increased, then that will be seen as a drop of efficiency. Another cause of pump efficiency, of course, is if somebody decides to try and control the flow by throttling the discharge valve, which will increase the losses on the discharge side, affect the system curve, and therefore cause the pump to operate at a different duty point, which may well be at an efficiency lower than was intended. Corrosion and possibly erosion of the internals of pumps can cause the fluid to be more turbulent than is preferable. That can result in additional losses, reduced efficiencies, and also at a larger scale, any restrictions inside the downstream pipe work, particularly on dirty water applications, of course. You can have partial blockages, obstacles, valves partially closed, any sort of restriction will tend to affect obviously the performance of the pump and will reduce its efficiency. Another potential cause of reduced efficiency is over lubricated bearings, and we'll look at that in a bit more detail in due course. When it comes to reliability and predictability, these are important, because if you've got unreliable kit or kit that doesn't operate as you would wish, you can end up with having to spend money on trying to rectify these issues. Unplanned activities always cost more than planned activities. So if you're having to send people out to a site that you didn't intend doing, it can be the middle of the night, it can be weekends, it can be expensive. There can be a premium to pay to get people in at short notice, or a premium to pay to get spares on short deliveries. So poor reliability and predictability can increase costs. They can also increase incidents, which also have a financial side, of course, but incidents on the clean water side can be customers going without water. Incidents on the dirty water side can be pollutions, for example, which cost money to rectify, and also have got an impact on the way in which people perceive the companies responsible for them. Unnecessary capital expenditures is another outcome of reduced reliability. We put kit in to notionally operate for a period of time, often to have a life of 20 years. If kit isn't looked after, it'll fail prematurely, and we'll have to spend money replacing it, and that's money that could have been better spent on in other areas. Kit that is not performing reliably will tend to require reactive maintenance rather than the predictive maintenance, which is planned and can be coordinated and done at an appropriate time. So if you've got a lot of kit that's not performing reliably, then you will have to spend more time on reactive maintenance. Your maintainers will be spending more time on that activity, and it gives them less time to do the work which is really beneficial on the preventative side. And as I alluded to earlier, if kit is being unreliable, then you tend to get failures. You can have if a bearing goes down that you didn't anticipate, that can cause other problems further down the line, and ultimately assets don't last as long as they were designed to do. So other reasons as well why we perhaps need to think about maintenance. Now, depending on who you talk to, the cost of maintenance in terms of a total cost of ownership situation varies, and it clearly varies between different types of pumps and between clean water and dirty water. It could be 5%. It's typically about 20% on dirty water pumps. Clearly, the highest cost element is energy, but the second highest is frequently maintenance. So there's a good financial reason for getting maintenance carried out. And the other thing, of course, is in a lot of cases, maintaining pumps is fairly straightforward. It's not that difficult an activity at a basic level. Now, I'm flying across the message of a number of other presenters over the last couple of days, I know, but I found this quote in a paper that said the first order of business is to establish a condition monitoring program that includes as many technologies that can be justified. Well, I'm not a Luddite, and I think a lot of the new technologies and the new tools that are available are absolutely brilliant. Some of the cloud-based stuff, the way in which data can be handled, the monitoring technologies are absolutely superb. But what I would say is that from a maintenance perspective, in the first place, you've got to get the basics right. And if you haven't got the basics right, you can use as many technologies as you like, but ultimately they'll only tell you that your kit is failing when it shouldn't have done. So I think getting the basics right is absolutely fundamental. So what sort of activities are essential when it comes down to pump maintenance? And the first category I've got here is what I've called routine monitoring, which essentially is just having a look and having a listen, looking for any leaks from flanges, seals, or bearings. If the bearings are oil lubricated, what do the oil levels look like? What's the colour of the oil? Are there any unusual sounds or vibrations coming from the pumps? What do the instruments say? What's the ammeter saying? Anything that the instruments are saying that's different to normal? Do the guards look okay? Are the guards still fastened down, giving protection to people working around the equipment? And I've put a final thing there, which is it's not really routine monitoring, but it's a really important point, which is that there are many instances where reset buttons have been reset and pumps have been restarted, and somebody walks away thinking that's great. But there are many instances where reset buttons have been repeatedly pressed without looking into the reason why the pump tripped in the first place. And ultimately, in many cases, that leads to a much more serious problem than the one that the pump had tripped out for. So really important, if a pump has tripped out, to try and get some understanding of why that happened in the first place. So in terms of routine monitoring, when should that be done? Well, daily or weekly, whenever somebody's at an installation, and at every opportunity really. Whenever an operator or maintainer's walking around the site, they might be focused on a job that's 20 yards away, but on the way, it certainly pays for them to just have a look at any pumps around, any other bits of kit, just to see if there's anything that appears not to be as it should be. All basic stuff. Quarterly, the sorts of things that are useful to do are to check the foundations for pumps, the support structure, make sure any bolts are still tight. Carry out lubrication if the lubrication schedule requires that on a quarterly basis, and also, and particularly of course, if there is evidence that some of the bolts potentially have become loose, to check shaft alignment, which in this day and age is a lot easier using some of the laser techniques. And on an annual basis, one of the maintenance checks that's really useful is to carry out a comparison between the current performance of a pump and the benchmarked performance. In other words, the performance that pump was exhibiting when it was first commissioned. And it's really useful to have that information available on day one, information such as the duty of the pump, the head and the flow rate, the motor current that's being absorbed, and if possible a vibration signature for the pump. And then what I'm suggesting on an annual basis, to go in, have a look at those that data, do a comparison, and that may give an indication that it's time to carry out perhaps a minor overhaul, or perhaps to adjust some wearings, or whatever's necessary to try and get the pump back to operating at its best efficiency point. So certainly for larger pumps, a really useful activity. Does size matter when it comes to how you're looking at maintaining your pumps? Well, yes, it does. Small submersible pumps can be relatively cheap to replace. They can also be quite difficult to access because they're down wells, and often they are relatively low on the criticality scale. Often because there'll be a standby pump there anyway. So when it comes down to some of the small submersible pumps, carrying out regular maintenance checks is potentially not a particularly good thing to do because of the costs and the risks of doing so, and the implications of the pumps failing, which may not be significant. But on the other hand, large water supply pumps are often critical assets. They're sending water to the customers. They're often expensive to replace, so a significant failure of a large water supply pump can be a real problem in terms of not just the cost of replacing it, but lead times. And often these pumps, quite rightly, because that's how they were designed, they're easy to access. So it makes sense to put effort into maintaining those pumps and visiting them regularly because it's relatively easy to do. So all of these factors, together with some knowledge of the service history, should be used to determine the pump maintenance regime. So just a couple of minutes on the importance of lubrication. All pump bearings will eventually fail. That's the nature of the beast. You will always, within bearings, have surfaces rubbing together, whether they're lubricated or not, and ultimately the products of friction will win, and the bearings will wear out and they will fail. But the reality is that in many cases, the reason that bearings fail is not because they've fatigued, it's because the lubrication hasn't been attended to. And it's really important to attend to the lubrication to maximise the bearing life and therefore the life of the pump. Looking at oil lubricated bearings, and there's a little picture on the right hand side there of a bearing which relies on a rotating through an oil bath to provide the required lubrication. But for these types of installations, it's worth noting that over lubrication can be just as damaging as under lubrication. If you've got too much oil in there, then the bearing's got to work as it goes through the oil. It'll draw more power, it'll generate additional heat, and that can reduce the effectiveness of the oil in terms of its ability to lubricate. If when checking the condition of the oil it looks cloudy, that may be because condensation has caused water to become mixed with the oil. That reduces the effectiveness of the oil as a lubricant, and in that case the oil needs to be changed immediately. When it comes to grease lubricated bearings, and of course many of the pumps out there have grease lubricated bearings. Some of them are sealed for life, so they're sealed with lubricant within, and no re-lubrication is required. But for bearings where additional grease does need to be introduced, it's really important not to mix greases of different viscosities or different types. And once again, over lubrication is something that really doesn't do the bearings any good at all. Leads to high temperatures and can lead to premature failure of the bearings. So it is a fact, though, that after putting new grease into bearings or possibly adding some more grease with a grease gun, the bearings are likely to run at a slightly higher temperature for a period of 1 to 2 hours. That's a statement of what you're likely to see, and we can see that on the top graph here. These three graphs are all graphs showing temperature on the horizontal, on the vertical axis, sorry, on the left hand side, and time along the bottom axis. And what's happening here, we're introducing new grease into a bearing, and you can see on the top graph the temperature of the bearing increases, and then at about sort of 50 minutes in this case, the temperature then starts to reduce until it gets back down to its correct running temperature. If you look at the graph at bottom left, that shows what happens if you have insufficient grease. So in that case, the bearing will run, won't run hot, but then because of a lack of lubrication, there'll be increased friction. Ultimately, that will lead to a rise in the running temperature of the bearing, and ultimately that will fail. When it comes down to, if we put too much grease into the bearing, you will get the rise in temperature when you restart the machine, but then it will continue to operate at that elevated temperature, which once again ultimately can lead to failure of the bearings. So just to finish off, the title of this presentation was about pumping stations. It isn't just about the pumps themselves, and with any pumping station there are other facilities that need to be looked at from a maintenance point of view. There are the instruments, of course, some of which may need to be cleaned or their calibration checked. Motor control systems need to be looked after. Ventilation systems, which may be there either to provide clean air in a location or to provide cooling air, need to be looked at. And you can see the picture on the right hand side was one I took at an installation. You can see the ventilation ducts there, about a third of them are, or good third, probably nearer 2/3 are covered in debris, so that's restricting the air intake into that ventilation system, which is not ideal, of course. And we also need to think about the operators and the maintainers who are going to be accessing these pumping stations. So we need to make sure that the lighting's right, the provisions for access are kept clean, hygiene facilities are up to scratch, and also to make sure that people have got the information they need. We need to make sure that the logbooks are updated, and anybody who's going down to do some work has access to operation and maintenance manuals, drawings, and any schematics. So a lot of those you would classify under housekeeping, but what I'm suggesting is that the maintenance really needs to take account of those things, not just focusing solely on the pumps. So in summary, maintenance isn't a compulsory activity, but if you don't want to carry out any maintenance, then you're going to end up with inefficient and unreliable pumps. For a lot of pumps, maintenance activities are straightforward. For a lot of small submersible pumps down in a well, there's not a lot you can do, but for maintenance, for pumps that are accessible, there are a lot of very straightforward checks that can be done, but they can be very valuable. Really important to look after lubrication. It's not the sexiest bit of maintenance, but really important to undertake that activity. Don't ignore the ancillaries, so that the other bits and pieces that make a pumping station work. And the final point, and really the key thing coming through this presentation, is focus on the basics. Yes, let's use all this great new technology, but we need to get the basics right in the first place. So that's the end of the presentation. John, if you're there, I'm happy to answer any questions now. If not, my email address is on the screen, and obviously I can also be contacted through the pump centre. So thanks very much for listening, and I hope you found some of that interesting.
Well, we've got some questions come through, Kevin, so okay. I'll start firing them at you.
Yeah.
So the first one is from Mark. What size would you suggest is a small pump and a large pump, in particular on a wastewater duty?
Well, I suppose that's very much a subjective judgment, isn't it? I mean, when I'm talking about small, I'm probably using that word to describe pumps that I'm not going to pay much attention to, as much as whether it's the physical size or the absorbed kilowatts. So I think it's when you're looking at pumps, and when I'm using terms like small and large, it's really looking at those which, by virtue of their criticality or their or possibly their size and a low replacement value, aren't really worth putting a lot of time and effort into to maintaining, and perhaps running to failure, which is quite acceptable. And so I don't think I'd want to give a sort of a kilowatt rating or a physical size. It's more about that sort of judgment, if that is a reasonable answer to the question. So it's not so much about the size, but just in terms of whether they can be allowed just to run to failure, or potentially you do need to look after them and do some intervention work on them.
Okay, Kevin. The next question's from Amol, and they ask, what interval is required to re-grease the bearing, and how do they understand that re-greasing is actually required? Right.
The factors that determine how often you have to re-grease a bearing are the size of the bearing and the speed with which it's rotating, and that data is provided by the bearing manufacturers. So they provide that information, and clearly that all then needs to be provided to the pump supplier so that they can inform their end client. So the frequency of relubrication and in fact the quantity of lubricant to be provided should all come from the bearing manufacturer, but it's those two factors. It's bearing size and speed of rotation.
Okay, question here from Robert. What do you see as being the greatest challenges to implementing pumping station maintenance?
I suppose it comes down, as so many of these things do, to whether or not organisations really understand the importance and take it seriously, because these things inevitably have to be led from the top. So if you've got an organisation that recognises the importance of maintenance, recognises the impact it can have, and recognises the impact that a lack of maintenance can have, then you're likely to get an organisation that's set up to maintain equipment, that's got the finances to back it up, and the people to do the work. So in terms of barriers and challenges to it, it really depends on how those organisations view maintenance as something to be looked at, and clearly if an organisation doesn't view it as being important, that's a real challenge to whether it's actually going to be undertaken, because you may not then have the resources, financial or manpower wise, to do the work that's needed.
Okay, just need quick answers for the next question. What are the considerations for maintaining pumping stations which are infrequently, if rarely, operated but are critical, e.g. flood protection, stormwater, etc.?
Well, and that's a sort of a classic problem that the Environment Agency have, of course, is that a lot of their installations are not necessarily visited and used very often. I think interesting question, because if something is really critical, you have to sort of ask the question, well, perhaps we should visit it more often. Perhaps we should make sure that the pumps will run. And often this is found with valves, of course, that don't open are not required to operate very often, that they sit there, and will they operate when they're required? Well, unless they've been exercised, they won't. So I think that there's a question within that question. If something is really critical, perhaps people ought to be visiting the installation and undertaking some sort of checks on it. That would be my answer.
Thanks, Kevin. I think we've now run out of time, so there are other questions. So any of the guys that have not managed to get round to your questions, if you could email your questions to Kevin at the email address on screen, then I'm sure he will respond to you. So apologies, we're out of time. So all that's left for me to do really is to thank Kevin for the presentation, and thank you all for attending. The next two presentations are going to be highlighted on the following slide, and I look forward to seeing you there if you can make it. So thanks everyone, and goodbye for now.